Okay, let's continue talking about these transformations. Again, a couple of earlier videos here talked about shifting, talked about stretching. We're going to call this a compression. When you talk about the word compression, you talk kind of like squeezing, right? Like shrinking it, making it smaller. A lot of times this is called a shrink. I don't like that word because it sometimes it connotates like dilation, okay, like shrinking into a miniature size, but that's kind of not really what's happening. We're going to do different videos that illustrate these different transformations here in a little bit, okay, but let's focus on the format and function notation and where we'll see these transformations, okay. So we said compressions are related to stretches, so these two kind of go hand in hand, because when we see a compression, okay, we still see a number that's being multiplied. So this is going to look the same, okay, as our vertical stretch, where there's a number in front of the function. The only difference here is, just like with stretching, we said if the number's big, it's going to stretch the graph. Well, in this case, we're looking at a number that's between 0 and 1, okay? So again, fractions, 1/2, 2/3, decimals, 0.2, 0.4, right? Those are all examples of numbers between 0 and 1. And then to give this, again, give it some context here, let's take a different function. Let's take a basic radical function, and let's say a new function g of x looks like this, okay? When we put this 1/3 immediately in front of the radical, not inside the radical, but in front of it, because this is happening in front of the function or outside the original function, we would call this a vertical compression. Okay, so again, it's outside the original function, right? It's outside the original function here, so we know it's vertical. It's multiplication, so we know that it has to be one of these two, and it's a number that is between 0 and 1. So that's how we know it's a compression. So we're really checking three things, right? Where is the operation occurring? Okay, what is its value? Okay, and what is the operation? Is it multiplication or addition? Like this was addition up here when we were shifting. This is multiplication, so we know it has to be one of these. All right, let's go over here to horizontal compression. Okay, again, similar to stretching, we're going to be multiplying a number by x in here, okay? But again, all horizontal transformations are the opposite of what you would assume. So when you think compression, squeezing, making smaller, right? That's what this word means, right? So that's why when we're doing the vertical transformation, we are using a fraction, because multiplying by fractions less than 1 make things smaller. What would not make something smaller, right? Multiplying by a big number, right? And that's where our horizontal compression comes in, because our horizontal compressions, right, are the opposite of what we would assume. So take this same example and say, okay, if f of x is equal to the square root of x, and here comes this other function that we call g, right? If we have a function that looks like this, where we're taking a big number, relatively speaking, 5, and multiplying it inside the radical. We talked about in an earlier video that inside means inside parentheses or absolute value, right? Or a radical symbol, sorry about that. That's where we know to see the horizontal transformations occurring inside these grouping symbols, okay? So here we have our compression transformations.